Swayam Prabha. Digital India. Educated India.
Research Methodology, Part 2, Lecture number 3. Now we will see more aspects of research methodology and how we need to plan it. So, first and the foremost thing is that we have to learn what is research methodology. Research methodology is the specific procedure or technique used to identify, select, process, and analyze information about a topic. In a research paper, the methodology section allows the reader to critically evaluate a study's overall validity and reliability. So, in any research paper, there are different sections, as I mentioned in the previous lecture. Now, that is because we have to understand what research methodology actually means and how it is done. Research methodology is very specific procedure. We have to first select a problem, identify a problem, select a problem, and then we have to process that problem in the best manner, and then whatever results we get, we have to analyze them. And this is how in any research paper you will see that there is a separate section which is called materials and method. And there the whole method is elaborately written down because it is important to understand how it works. What do we learn in research methodology? Becoming familiar with the research methods used by an area of study allows you to understand it more effectively, because many different types of research designs can be used. This is especially important for the study of human growth and development. Different research methods also have different levels of validity. So now, to appropriately choose the right method, we saw that there are different types of research design depending on whether we are doing research in science or social science or in humanities or in commerce or in computer science. The treatise is very, very different. It is not the same as what it is supposed to be. There is no universal or single method of research. For a different subject, the treatise becomes completely different. Different variables, different parameters, different processes, and so on. And therefore, their levels of validity also change. So that is what is being, emphasized in this lecture. Now, as we already know, that there are different types of research methodologies. There are main types are based on methods for collection the information. One is observational, second is experimental, third is simulation, and fourth is derived. And in the previous lecture, we saw that how these observational data, experimental data, simulation data, and derived data are impacted by the different variables. Not only that, the treatise of any research in any sphere, in any field of science, arts, commerce, computers, whatever technology, is based on these types of research, any one of them, or maybe more than one. So that is what is to be understood very clearly. The type of research data you collect may affect the way you manage the data. For example, data that is hard or impossible to replace, that is the recording of an event at a specific time and place, requires extra backup procedures to reduce the risk of data loss. Or if you will need to combine data points from different sources, you will need to follow best practices to prevent data corruption. So we had touched upon this topic also in the previous lecture, where I had mentioned that such incidences where the recording is done at a specific time, space and place and such events cannot be replicated. So the data has to have a backup. And similarly, if these data are kept in computer, they should not get corrupted. The computer should have something like virus dealing softwares like Quick Heal and many such softwares. So they are then responsible for not letting the data getting corrupted. Observational data, as what we learned in the previous class, observational data are captured through observation of a behavior or activity. It is collected using methods such as human observation, open-ended surveys, or the use of an instrument or sensor to monitor and record information, such as the use of sensor to observe noise levels at the megapascal levels in St. Paul's Airport. I gave this example, and this example was very common. It could be any airport. I have just chosen this because there is a monitor or an instrument that can record this information. What is the noise level? It could be a bus stop, it could be any public place, even a marriage hall where there is immense amount of noise. Now that noise level at that particular time can only be recorded. If you try to record that information at another time, it may not be the same. So that observational capturing of the real time is very, very important. And therefore, observational data have their own very significant role in research. And once they are lost, they cannot be recreated. So this is what it means. Now, experimental data. Experimental data are collected through active intervention by the researcher to produce and measure change or to create difference when a variable is altered. Experimental data typically allows the researcher to determine a causal relationship and is typically projectable to a large population. This type of data are often reproducible, repeatable by others. So experimental data, there is no problem about preservation or keeping the data because they can be reproduced by doing the experiment. If I am doing one experiment and I have got a certain result, now that certain result is something that will be found every time I repeat the experiment. Whether I repeat the experiment or somebody else repeats the experiment, the final data will not change if it has been done in the procedure that is mentioned in the process. Simulation data. Simulation data, as what we learned in the previous lecture, are generated by imitating the operation of a real world process or system over time using computer test method and models. For example, to predict weather condition, economic models, chemical reaction or seismic activity. So this we learnt in the previous class. It is repetition because I want you to understand it very carefully that these occurrences or this simulation data usage is in various fields. It is not just for weather prediction. It is not just for giving the economic model or to say whether the chemical reaction will occur or not, or whether there will be any tsunami or not. It is more for understanding that such things can be predicted based on a given set of information. This method is used to try to determine what would or could happen under certain given condition. So it is more like you are simulating that atmosphere of that reaction condition and then predicting the results. The test model used is often as or even more important than the data that is generated from the simulation. So what it means that we have a certain set of reactions, and these reactions are copied in a non-experimental condition, and with the help of computational algorithm, advanced information can be predicted based on the given set of data. So that is called simulation data. Now, derived and compiled data also we covered in the last lecture. Derived data involves using existing data points, often from different data sources, to create new data through some sort of transformation, such as arithmetic formula or aggregation. For example, combining area and population data from the Twin Cities metro area to create population density data. So if such a thing has to be done, one is derived based on the previous data that was collected, or it is compiled together. It is extended. While this type of data can usually be replaced if lost, it may be very time consuming and possibly expensive to do so. So you have to preserve these data, because once you have done all the calculations, you can't afford to lose it. Although one can derive it once more, but it will be very time consuming. It will be also monetarily expensive to do that whole exercise all over again. So what it means that overall, these data, different types of data, that is observational data, experimental data, simulation data, derived and compiled data, have their individual roles to play. And they in their own field are very significant in research methodology. Now, as what we had learned even in the previous lecture, there are different types of research based on whether it is a quantitative research, whether it is qualitative research, whether it is descriptive research, analytical research, applied research, fundamental research, exploratory research, or conclusive research. Which means that in each case, the treatise of the research is very different. Quantitative, the moment you hear that word quantitative, it means that it has to do with the numerical value. Whether X gram will be formed or 2X gram will be formed in a particular experiment, that kind of research. Qualitative is whether or not the reaction will take place or not. Yes or no. Whether a treatment can make any difference to the in the dyeing process of the silk material, whether any chemical auxiliary has any impact or not. Qualitatively, one can find out yes or no, acceptable, non-acceptable. Descriptive research is when you have a description, which means that you do from 1 to 2, then you go from 2 to 3, and then 3 to 4, and then finally 5th is your final step. So these are descriptive research where they are dependent on different types of the steps that are needed to be described. Analytical research means where the research is based on totally analytical instruments, where you are doing a reaction and then you are analyzing your substances with instruments, and the analytical data then becomes very important to identify that product. Applied research. Applied research means where you are trying to find a solution for either a societal development, or whether you are trying to improve any product from X stage to Y stage and from Y stage to Z stage to make it better. Fundamental research is where you are looking for answers of very basic problems. So they, as the name suggests, they are directed towards the research that is completely dependent on the basic fundamentals of science. Exploratory research. This is more for finding out whether or not a particular research design will work or not. And therefore, it is more of exploration or the possibility of research going in a positive direction. And conclusive research is when you are trying to do research which has some concrete answer, a very conclusive answer. Yes, this will happen. That kind of answer, when you get, it is under the category of conclusive research. Or if you are trying to explain a hypothesis and you have conducted experiments to prove that why this product only forms and not the other product, that is also a kind of conclusive research, because reaction mechanisms are very well defined. It is not that the reactants will choose to react in one manner one day and under the same condition they will behave differently. No, that never happens. Unless and until the conditions are altered, the product that will be formed will be the same, and that comes under the category of conclusive research. What are the problems that are encountered during research? Because these are very basic issues which one should understand and know. As a researcher, when you start your journey, you should be able to see how to do, what to do, when to do, what are the don'ts, what are the do's. If you know that, then your path on the research journey will be very smooth. Otherwise, you are bound to make mistakes. Mistakes will still happen, but by learning this particular set of lectures, you will be able to avoid many common mistakes, common challenges, common difficulties. The study explored various common challenges and difficulties during writing the research proposal and projects, such as difficulty in deciding the research topic. Because this is the basic step from where the journey begins. And therefore, sometimes for a student it becomes very difficult to select a topic on his own. Here, the guide helps to select the problem because the student is still new to the field of research and will not be able to think of an independent problem on his or her own in the beginning. Therefore, the guide helps to find out how to find a suitable research topic. Lack of good knowledge of the methodology, inability of finding modern, specialized, and related references, and lack of interest in research. Now, there are many challenges. Of course, lack of interest in research is very deadly. If you don't have any interest in research, it is better not to pursue. Many students come to me and they have this rosy idea of doing research. It sounds very stylish to say that I am doing research, but then it takes a lot of time, energy, and dedication to do research. Let me tell you this very frankly. And in the beginning, of course, everything that appears rosy is not really rosy. It is that because you do not have good information about the methodology, how modern research is done, sometimes, or even step-by-step guidance from the guide is very essential. Where to look for literature survey, how to see the references, how to decide a topic. There are many such problems which the student encounters. However, nobody can deny that there is great importance of research. And that's why one has to learn. Anybody who is an aspirant of MSc program or PhD program in any field must understand what is the importance of research. It is the most valuable tool to understand the complexities of a problem, disapprove lies or myths, uphold truth, and build on to create knowledge that is reliable and authentic. Conducting research develops a better understanding and enhances decision-making capabilities. So, in order to understand research, it is very important that one should be able to find out how research has to be done. Just by thinking that I want to do research, it is very stylish, my friend is doing research, so I should also do research, is not what is going to lead you to do research properly. The whole process is very complex, as you must have understood by now. But if you have a clear-cut idea that you will do what you will do very truthfully and create new knowledge dependent on the knowledge that is existing, but adding new scientific information through your research, which is reliable and authentic. All these words are very deep-rooted meaning words. Reliability, authenticity, creating new scientific knowledge through your research are the key words. If you can understand and appreciate them, then you will be able to understand that these are very important, words and criteria to do research in a very systematic manner. Conducting research develops a better understanding and enhances decision-making capability. Now, when you do research in a particular manner, by understanding why you are doing this problem, what will be the outcome according to you, thinking of that, whether you can prove that hypothesis, all that must be all the time going on in your mind to find a solution to the problem that you have posed for your research plan. So, purpose of doing research, because there has to be a purpose. It is not like randomly walking in a park. It has to have a very concrete decision that you have decided to do this because you have a purpose. You either want to do an exploration work, or you want to do a description work, or you want to do a hypothesis that you want to explain through your research. There has to be very, very discrete purpose of research. Unless that is clear in your mind, you cannot proceed with research in a very efficient manner. Because these processes, these explanations, exploration, descriptions have to be clear in your mind. There should not be any clouding in the mind, whether I am doing exploration, whether I am trying to describe, whether I am doing explanation. That should not be any mind-boggling effect on this. Everything should be very clear that you are doing research for exploring whether or not this reaction will take place or not. It should be clear in your mind that description of the research purpose should be absolutely clear in the mind, knowing what is the purpose of reaction 1, 2, 3, 4. Only then you will get the product 5. And if 5 is formed, then all that you have designed from 1 to 2, 2 to 3, 3 to 4, 4 to 5 is justified and was very clear in your mind that this is how the reaction should proceed and has proceeded. Similarly, if you want to explain an hypothesis, then you have to have a very plausible explanation for proving that this hypothesis of dye uptake enhancement, for example, is due to the auxiliary, and the auxiliary is actually chelating in a manner that it is taking dyes very readily, or the capillary action of the dye solution through the fabric is enhanced due to proper channeling of the warp and weft fibers. So any one of these explanation which you have put as an objective, you can explain through this very clearly if your purpose of explanation is clear in your mind. Whether or not, and that would reflect whether you understand research that you are doing, or you are just mixing two things and trying to see the result. That is not how research has to be done. Research is a very methodical way of conducting experiments. And when you do it in a methodological manner, you are bound to get results. The results may be acceptable or rejected, but at least you have honestly planned and understood the planning before planning and executing. Purpose of research, where you are information gathering and or exploratory. That is, you are discovering, uncovering, exploring. Descriptive, that is gathering information, describing, summarizing. So whether you are doing any kind of survey, suppose you are a student of social science and you are asked to do a survey on a particular subject, whether or not there are more vegetarian people than non-vegetarian people in a gathering in a city or in a small area, then you are actually just discovering what is the number? What are the numbers that show that you have more of vegetarian people and less of non-vegetarian person, or vice versa? So that also is collecting information, and that comes under the exploratory purpose. Then there is something called theory testing or explanatory. Testing and understanding causal relationship. Predictive, because predicting what might happen in various scenarios. So you have different scenarios, and you can, on the basis of theory testing, you can actually explain that this is how the results are going to be obtained. So it's more or less you can predict. There is no exploration. There is explanation based on the understanding of the relationship between the problems. And therefore, that prediction is very scientifically proven, that you have taken the past information and you are trying to explain it on the basis of the exploratory purpose of research. There are several barriers in research. I don't want to scare you, but I also want you to understand that everything comes with its advantages and limitations. It is not that one thing has only advantages, the other thing has only disadvantages. It's a mixture. So there are several barriers in research too. Among the existing organizational barriers, the limited access to information sources, lack of facilities and equipment, time-consuming bureaucracy, inadequate income of research activities, and demotivating authorities and professors are the most frequently reported research barriers. Now, I've added everything here, which means that, say you belong to a small college of a small village, you don't have many facilities or equipments in your own college. You will be totally dependent on your analytical services in another town, in a bigger town, in a bigger lab, where there will be a lot of load of sample analysis. So obviously, it is time consuming, because we will first go and submit the sample. They will analyze it according to the queue after 20 days. And then, so time will be lost in all this bureaucratic, timing. Then, because research consumes a lot of money, you have to buy chemicals, you have to use electricity, you have to conduct experiments, you have to buy glassware. So sometimes in many small colleges, these facilities are not available. And then over and above, you don't have good library to go and do good literature survey. So the professors and other, authorities make very detrimental remarks that, oh, you cannot do research in a given condition. So these are all research barriers. But nevertheless, there are agencies which give students some kind of stipend and some research funding, but then those are competitive examinations where you can apply for junior research fellowship or senior research fellowship and get money to do your research. They even give stipend to the students along with a research grant, which can be used for buying chemicals, for attending seminars, for buying glasswares, and even for getting your samples tested. But then these competitive examinations are not very easy. So very few students get selected, but nevertheless, those who get selected get this funding. So it is a kind of a barrier, but a barrier that can be crossed. So What I am trying to tell you, I am not trying to dissuade, but I am trying to tell you that there are limitations when you get into this journey. And when you get into this journey, it is not easy to be able to overcome all the barriers. Institutional barrier. Among the existing institutional or organizational barriers, the limited access to information sources is one of the major problems. Many of the local colleges cannot subscribe good journals because the charges for good journal subscription is very high. Thanks to the fact that now Google can give us a lot of information we can download, or Sci-Hub can give us, but in many times latest journals cannot be downloaded through Sci-Hub. So you have to be dependent on ScienceDirect.com and other SciFinder type of sources, and these are all paid by the institution. If the institution doesn't have funds to source this, then that is a big institutional barrier. Lack of facilities and equipment, as what I mentioned, in many of the local colleges, they do not have good equipments because everything costs money. They may be running a research program, but may not have a laboratory well equipped to do experiments. Or they may have very basic equipments in the laboratory which may not be adequate to do, advanced research. As a result, telling the authorities to buy equipments or to arrange equipments somehow is also very time consuming. First, you have to give an application to the head of the department through the guide, and then if the guide feels that it is worth buying that, then he will make a recommendation. Then it will go from one office to another office to finally purchase office. Then the purchase office will get 3 quotations, and then there will be a tender system and all of that. All this is not only time consuming bureaucracy, but it requires a lot of patience from the student's side. Inadequate income of research activities and demotivating authorities and professors are one of the most frequently reported research barriers. I just now told that sometimes even the HODs will say that, okay, this research was not required to be done. This problem, what is it going to solve? If you are doing a research in a particular field, how is the department going to get benefit? Are you going to get a good publication? Now, how can you predict that you will get a good publication before even doing the research? So these are certain demotivating things that happen, and therefore it is very important to understand that how to overcome institutional barrier. Now, coming to categories of research, there are 2 main categories of research methods, and we have learned this in the past: the qualitative research methods and the quantitative research methods. Qualitative research relies on data obtained by the researcher from first-hand observation, interviews, questionnaires, focus groups, participant observation, recordings made in natural settings, documents, artifacts. The data are generally non-numerical. So as the name suggests, these are very qualitative in nature. And it is just that a questionnaire is circulated or a survey is done. Then these are based on the interviews, how a participant is observed to say certain things in a gathering, and recordings are made in natural setting. and they are not in any numerical form. That means they are more of qualitative nature. Whereas the other type of research method is quantitative research, where the research method involves using numbers to measure data. Researchers can use statistical analysis to find connections and meaning in that data. So, suppose you are doing research where you are trying to make aspirin in the laboratory, and you have made it by two different methods, and then you have modified the third method by making some improvement on the method number 1 and 2, and your third method gets a yield 2.5 times more than the 1 number method and the 2 number method. So obviously there is a number involved which is playing a qualitative role in that, quantitative role in that. So it should be understood that qualitative means it is more of one-to-one discussion, questionnaires, interviews, and so on, recordings, whereas quantitative research means it is dealing with some kind of improvmental numbers. From 4 grams it has become 6 grams, from 2 grams it has become 2.5 grams. So that kind of incremental benefit comes under the quantitative research method. Now in this slide, which I have sourced from Question Pro, and I'm giving the data source. Why? Because it was not made by me. Repeatedly I'm telling this because when you are taking any information from public sources, you need to tell what is the source of your information. So qualitative research means one-to-one interview, case study research, focus group, ethnographic research, process of observation, or record keeping. These are different headings of qualitative research which is done by social scientists, by many art subjects, PhD holders or PhD persons who want to do PhD in the field of art. They are following this qualitative research methods. Whereas in quantitative research, which I have sourced from Wall Street Mojo, it is not only just the survey research or the correlation research or casual comparison research, it is also based on experimental research. So quantitative research could also be categorized into all these different types of research because they are now very interrelated. Survey research can give some correlation. Correlation research can give casual comparison between the research methodologies, and that could lead to design and experimental research which will be very concrete and very well designed. Now if we try to look at the comparative data of qualitative and quantitative research, conceptually and in method, this I have sourced from Minchilo et al., a paper published in page 5 of the year 1990. So conceptually, qualitative means it is concerned with understanding human behavior from the informant's perspective, assumes a dynamic and negotiated reality. whereas quantitative is concerned with discovering facts about social phenomena, assumes a fixed and measurable reality. So the treatise is very different. And when the treatise is different, it kind of also explains that how qualitative is different from quantitative. When it comes to methodological concept, data that are collected under qualitative are through participant observation and interviews. Data are analyzed by themes from descriptions by informants, whereas in quantitative, data are collected through measuring things. Data are analyzed through numerical comparisons and statistical interferences. In qualitative method, data are reported in the language of the informant, whereas in quantitative, data are reported in numericals and are analyzed through statistical analysis. So that is a major difference between the two. Now, one would come to the expression, what is the final goal of research? Why should we at all do research? Why is research important? The main purpose of research are to inform action, gather evidence for theories, and contribute to developing knowledge in a field of study. The significance of research and the many reasons why it is important for everyone, not just students and scientists, is the societal benefit and addition of new scientific knowledge. So there is a discrete improvement, discrete goal. Unless you have a goal, you can't reach the goal. That design of having a goal in the mind while setting a research plan is very important. First, the researcher has to ask, why is research important? Why am I doing this research? What is the purpose? And if I am doing research, what am I trying to prove? Am I trying to show that one reaction is happening, the other one is not happening? Or I am trying to find an evidence of why this theory is correct and this theory is incorrect? Or whether I am adding some new scientific knowledge to a field of study. This goal should be absolutely crystal clear in the mind of the student, and then only he should or she should proceed. Because if the mind is not clear, what is the purpose? What is my goal? Why am I doing research? Is it fashionable to do research and that's why I am doing? Is it because my friend is doing, that's why I am doing? That is not the purpose. Your research journey is just your sole research journey. All the barriers, all the successes are yours. You will share them with nobody. So that goal should be very clear. The purpose should be very clear. How to judge the seriousness of research? Now, I was told, okay, I will do research by a student. I was not very sure whether he has that capability of doing. So I asked him the following questions. For judging any research, these are very pertinent questions that come to mind. What is the topic and title that you want to do research on? What will be your objectives of doing research? Do you have enough information as to what is significance and importance of research? why you want to do, what is your goal, what is your purpose. Total expenditure on research, do you have any idea how much money will be spent? Who will spend that money? Where will that money come? And do you know, research doesn't happen overnight. It is a time consuming process, minimum 3 years, maximum 5 years as per the UGC law. So University Grants Commission has given this time duration during which a researcher should finish the research that he has taken up. So in such a case, how does the student researcher proceed? Unless these questions are really clear in his mind. Then, what is the nature of research? Why you want to do research? Fine. But what is it that has triggered for you to do research? So, research is a creative process. It is complex and iterative. Iteration is the repetition of process in order to generate a sequence of outcomes. Academic, it is curiosity driven. Developmental, application driven. Now, I will give you certain examples which will make these terms a little clearer to you. Research is a creative process. Just the way a painter creates a painting, a researcher creates new knowledge, and it is a very complex process and it is iterative. That means you have to repeatedly do that in order to prove the final outcome has a repeatability or reproducibility. It could be that it is an academic curiosity, that you want to prove that a particular hypothesis which was given by, say, any big scientist. At that point in time, there were not many instruments available. There were not many facilities, so they couldn't find a plausible reason for that. But it was more of an observational research that they did. Now, in order to prove that their observations were correct, you are doing a hypothesis recheck by validating that. So that is curiosity driven. Whereas a developmental research could be that there was a pesticide which was developed, but this pesticide, X pesticide that was developed in the laboratory was not tested for human testing. They thought, okay, it's only meant for pests. Pests are small creatures, they will die. But it had a long-term impact on the farmer who was spraying that, because every day he was also inhaling. When he was inhaling, a very small quantity was going into his system and getting bioaccumulated in his body. As a result, at one point in time, it showed its manifestation. So, it was thought that this is now not safe for human use also, although it was used against pests. So, people started looking for pesticides which were not having any human impact. So that is the developmental kind of research, which is application driven, where applying a safer chemical versus unsafe chemical was the main goal and purpose. Now, when you look at this is adapted from a slide made by President U of Twente. Here, research could be driven by many factors, but he has basically selected three main sectors. Science driven, where you are trying to improve the understanding of basic research and then existing understanding are improved through basic research. Industry driven, where you have an existing technology through applied R&D, research and development, and innovated or improved technology could be developed for the industry. And the third one is societal driven, which is you have a certain existing norms, and in the context of use, inspired by research, you come with an improved version of that embedding, which means that you have a concept. Now, with the modern tools, you have improved that concept, and therefore it has impacted the society. So this is what mainly drives any researcher from any branch, be it science, arts, commerce, technology, computer science, anything, pure science, statistical science, etc. So what drives research? Because if this concept is not clear to you, you will never be able to appreciate why we are doing research. Research is driven by several motivating factors that encourage scientists and scholars to investigate, discover, and create new knowledge. These factors help in advancing science, technology, and society. The main factors that drive research, first and foremost, is curiosity and desire for knowledge. Unless you have that curiosity, unless your mind is curious about knowing something, you are not fit for research. The primary driving force of research is curiosity. The desire to understand unknown facts and explore new ideas. Second is problem solving. Research is often conducted to find solutions to scientific, technological, social, or environmental problems. Third is innovation and discovery. Researchers are motivated to develop new theories, methods, products, or technologies. And fourth is academic and career development. Many scholars conduct research to earn academic degrees, publish papers, and build professional careers. So, there are many factors, even more than this. But these are the four basic factors which drive a researcher to do research in the most concerted manner. So, let us go into a little bit of more elaboration to understand what drives a research scholar. Several factors motivate or drive a research scholar to conduct research. These motivations help scholars explore new knowledge, solve problems, and contribute to scientific advancement. First, of course, as I told you, curiosity and desire for knowledge. One of the main drivers is intellectual curiosity, the desire to understand how things work and to discover new knowledge. Unless a researcher has this basic quality, he or she should not pursue research. If you're not curious why your reaction did not take place, how will you think of changing the variables? So, that basic curiosity must be there. Second, solving practical problems. Research is often motivated by the need to find solutions to real-world problems in areas such as science, technology, medicine, and society. For example, improving methods of textile dyeing or developing safer chemicals. This is a big problem solving situation because in today's time, textile mills are the most polluted or are the most big pollution indicators in the environment. And if they are not controlled, if there is a drive to find safer chemicals, it is going to be a very drastic situation. And in such a situation, to find solutions which will be biodegradable or chemicals which do not persist in the environment is the safest thing to do. Academic and professional growth. A researcher is helped as a scholar to obtain higher degree, that is PhD degree or postdoctoral work. In the process, he gains recognition in that field and builds a strong academic career. Fourth is innovation and development. Researchers aim to develop new theories, methods, technologies, or products that can benefit society. Fifth is contribution to society. Many scholars are motivated by the desire to improve quality of life, environmental sustainability, or industrial processes through scientific discoveries. Personal satisfaction. Research provides intellectual satisfaction and achievement when a new discovery or solution is found, or when there is an applause for your work, when there is an award that is awarded for your technology development. That is so satisfying for a researcher that often people think that a professor who is indulging in research has lesser money than a businessman, but he is a happier man because he is very intellectually satisfied. Whatever knowledge he has gained, he has utilized that knowledge to make something good for the society, and that itself is a big achievement. What a research scholar works on. He works on identifying a research problem, then goes to reviewing literature, formulating hypotheses or research questions, and then designing experiment or studies. So, for identifying research problem, a research scholar studies the subject and identifies the gap or problems that need further investigation. And I gave you an example that scientists in the 18th century or 19th century, they postulated some laws. Now, at that time, they did not have equipments to prove their laws by scientific backing. And if some physicist can find a solution by modern technologies, by equipments and prove that yes, whatever was the results obtained are very correct, and these are the hypotheses which are testifying that the hypothesis is correct, then it is of great use. So finding a gap, what needs to be explained and what is the problem, and then investigating. Reviewing literature. They examine previous research papers, books, journals to understand what work has already been done in that area. There is no point in repeating the same work because then you cannot get any credit for adding any new science. You're only repeating somebody's work. But if you find that, okay, he has done up to here, I can change the condition and see what is the outcome of that reaction. That can give a concrete new addition to research information. Formulating hypothesis or research questions. They develop research questions or hypotheses that guide their study. Designing experiments or studies. A research scholar plans research methodology, experiments, surveys, and analytical procedures to collect relevant data. So this way, they are very well equipped with the information and they understand that how a research scholar should work. Data collection, they gather information through experiments, surveys, or questionnaires or observations. Then, laboratory analysis, data analysis. The collected data is analyzed using statistical and scientific methods to interpret the results. Drawing conclusions. Based on the analysis, the researchers draw conclusions and explain the findings. Writing research papers and thesis. Research scholars present their findings through research papers, thesis or dissertation, conference presentation, and so on. So once the researcher has done that work, there is a way to formulate. We will spend a lecture on how a research review is written, how a research paper is written, how a research proposal is written. Moving on, what more the research scholar should work on? Developing new knowledge or technology. Their work often leads to new discoveries, improved methods, or innovative technologies. A research scholar is a person who conducts systematic investigation to discover new knowledge, verify existing theories, or solve scientific or social problems. Their work may mainly focus on research activities in a specific field of study. Because somebody who is doing research in chemistry, in a particular organic chemistry field, in a particular natural product chemistry field, will stick to that area because there his understanding through literature has become very vast, very deep rooted, and therefore he can conduct that research very well in that area. Characteristics of a good scholar. Curiosity and love for knowledge is the basic criteria. A good scholar has strong desire to learn, explore, discover new ideas. Critical thinking. They can analyze information carefully, question assumptions, and evaluate evidence logically. Discipline and hard work. Research requires patience, dedication, consistent effort for a long period of time, 3 to 5 years. Creativity and innovation. A good scholar develops new ideas, methods, or solutions to scientific or academic problems. And lastly, honesty and integrity. Maintaining ethical standards, avoiding plagiarism, and reporting accurate results are essential qualities of a scholar. Of course, there are many other characteristics like should have a good observational skill, should have good analytical ability, should also have good communication skill, and should be open-minded with perseverance. Because for research, patience, perseverance, and practice are the 3 P's that one should always remember that are required to become a good research scholar. So if I have to conclude, I will say a good scholar combines curiosity, critical thinking, integrity, creativity, and perseverance, which helps them contribute effectively to the knowledge and scientific advancement. So with this, we will say that in conclusion, the research scholar spends a lot of time not only in planning the research but also executing the research. Thank you.